Hello everyone, we are Team MB401. The core value of our algorithm and structure is to reuse the comparator and reusing modules. We will use a high-speed, area-efficient digital comparator to realize the comparison, which will be mentioned later. First, the algorithm. The algorithm is, first, the serial input IoT data. We're turning it into hexadecimal, from hexadecimal to binary. Then, using a functional select input signal to choose which mode to use. We can separate the mode into three different parts. First, if we are finding average, we will enable this part, and the binary value will go through an adder, which adds them all, and a divider to divide 8, which means that it's a shifter and right shift 3-bit. Second, if we are finding maximum or minimum, we'll go through an 8-value comparison, which we will enable it, and we'll get the maximum or minimum value. If we're finding peak maximum value or peak minimum value, we have to enable the first comparison and the second part of the comparison. After the first comparison, we'll get the maximum value or minimum value. And after we're getting it 12 times, we'll be into the second comparison part. The first 8 value will be in the first 8 value comparison. After the comparison, the maximum of it will goes into the second comparison with the 4 left values. So there will be 5 values if we are finding the peak maximum. We'll add in 3 zeros. Then the maximum value will be the peak maximum value. And if we are finding the peak minimum value, the same, we'll do the 12 minimum value, and we'll go into the second comparison. The first comparison of it will be the 8 values of the 12 minimum. And the minimum of the first comparison will goes into the second part of this comparison, which adds into 5 values as before. The 5 values, and there will be three empty values. So we will add in the 3 maximum value of it. So the maximum value of it will be 2 in the power of 128 minus 1. We'll add in 3 of it. The minimum of all will be the peak minimum. Then the third part, if we want extract or exclude, we will enable this unit. This unit is composed of a comparison of 8 values and 2 values. Since there are 8 values, we compare it with the high or low, so there will be 1 value left. And the left value will be also compared. So if we continue doing this of the low value or the high value, we're going to get the extract or exclude. If we are finding extract, then the value will be higher than low and lower than high. If we are finding exclude, we include the data lower than low and higher than high. The system architecture. First, we use a decoder to change hexadecimal. Our input is hexadecimal into binary. Then the value go through a comparison and control circuit, which the mode of it is controlled by the function select signal, is an input signal, and the function should be selected by it. If we are finding the peak value, peak maximum or peak minimum, we will need a register and then a comparator after it. If we are finding average, an adder, and a shifter is needed. If we are finding extract or exclude, the low and high value should be input into the comparator and compared with all these numbers. Then we will get the extract and the exclude. Known and to be learned issues. In comparison and control circuit, the position of mux multiplexer is in the late stages, just before the output. And all mods must be operated once before the output is determined, which may waste too many resources doing unnecessary calculation, since we don't need extra of it. We only need one of it. So we have changed it. We should consider moving the multiplexer into the earlier stages, so we can only operate the function that we need, and to prevent the waste in the further progress. Another is using 12 values comparator better than using 8 values comparator. Since we all use the 8 value comparator, it is a question that when we are finding peak max or peak minimum, there are 12 values input. If we use 12 value comparison, then we don't need to add extra values into it. And if we are using 12 maximum value, we don't need to do 2 comparison of it. However, we're going to add extra values into other comparison when there are not enough of 12. Now, next, to-do list and team member job assignment. We have to complete the structure of 512-bit comparator and complete the structure of comparison and control circuit. A team member job and assignment. 50% of data collection and PowerPoint grade, and me, 叶伟志, 50% of data collection and PowerPoint grade. And this is our project work schedule. We'll have module concept adjustment from week 1 to week 2. Realizing modules from half of the first week to the second week. Test bank check in second week. Logic synthesis in the second week and third week. And that's report writing on third week and fourth. Now, the last one, possible issues and expected solutions. If we compare the whole input value by value, the issue of it is huge area and low speed. However, if we compare the value bit by bit as a flowchart, it will be faster and save area. The flowchart is to compare the n-1th bit, which is the most significant bit. First is the bit of A is the bit of A equal to the bit of B? If yes, stop comparing. It means that we have to move on to the next bit. If no, we check if the bit of A is not 1. If no, A is greater than B, and we'll stop it. If yes, A is less than B, and it will stop. So finding the first most significant unequal bit pair and check the value of it is the solution of high area and low speed of a comparison circuit. Now, we have to work on how to expand the comparator into 512 bits. And this is the module of the circuit. And this is what we have to do in the next week. This method is from IET Journal, July 2020, Volume 14, Issue 4, page 450 to 458. You can get all these from in the journal. Thank you for listening.